Hello and welcome to section 9.7, which is on similarity transformations. A similarity transformation is a composition of rigid motions and dilations that map pre-images to similar images. So now we are combining making something smaller and bigger along with our reflections, translations, and rotations. So here's my example. Triangle LMN has vertices of -4, 2, -3, and -1, 1, and I have graphed that already. Suppose the triangle is translated 4 units to the right and 2 units up, and then also dilated by 0.5, with the center of dilation at the origin. Graph the pre-image and the image. So when I do these, I normally graph both transformations, even though realistically you would only have to graph the last one, but it's easier for me to see it if I do both. So I'm going to go do my translation first, so 4 to the right and 2 up. So each point I'm going to take 4 to the right and 2 up, which would make my new L right there. My new N would be right there, and my new M right there. And I'm going to go ahead and actually draw in the triangle just so I can see what's going on with it. You don't necessarily have to write down the new points. I like to, just because then I can see what's actually happening. So 4, 0, or excuse me, 0, 4, read that backwards. The new L is right there. The new N is at 3, 3, 3, and the new M is at 1, -1. That's a mess, but hopefully you can still read it. Okay, so there is my new, those are my new points, and then from there it says I need to dilate that by 0.5. So I'm dilating this by 0.5. So L, if I take half of that, would be 0, 2. M would be 0.5, -0.5, and 1.5, 1.5. I'm just taking half of these points. And then I could go ahead and plot my new points. So 0, 2 is right here. It's going to be, oops, it's kind of going to be on top of the last one I just did. So 0, 2, 0.5, -0.5, about right there. And then a 1.5, 1.5, it's kind of hanging out in no man's land right there. And if I want to go ahead and graph that, that's right there. So my second L, my third, actually those are my third ones, I guess, right there. So again, I like to do the in-between one, which is this one, just because then it's easier for me to see what's happening. Could I have done the half first and then went 4 to the right and 2 up? You should get the same answer. I just went in the order that they gave us. Okay, so that's one type of thing you might have to do. Then they might also give you the two figures, and you might have to figure out how they got it there, like this one. So it says, what is a composition of rigid motions and a dilation? So they're telling you it is dilating for one of them, and then it's doing something else also. That will map your original ABCD onto MNHP. And the key here is, look at how this is ordered. A matches up with N, M, B with N, C with H, and D with P. And so keep that in mind when you're looking at what's happening here. Now, obviously, if you look at the difference between these, this column is half of this column, so you know there's probably a dilation of 0.5 there. And what else? How did it flip? How did A, which is right here, go to M, which is over here? So if I dilate by 0.5, everything would shrink by half, right? So I'm just going to kind of jot this down here to try and see if I'm on the right track. Taking half of each one of these points. Okay, so that's where the points would be. So -3, 1. So if I dilate it, that would be the new A, and now the M is over on the other side of the y-axis. So it looks to me like what happened was dilation of 0.5 along with reflection across y-axis. That's how you write that. So it dilated by 0.5, it got half as big, and then it flipped. It reflected, I don't know if I said rotation or reflect there, it reflected across the y-axis. Okay, so they might give you the 2 and make you figure out how it got there, or it might give you the starting point and then make you figure out where it's going to move to. So bring that knowledge with you, and we'll talk about it more the next time I see you. Have a good night.